Hi, I'm Dan. That's my GitHub and my Twitter, so you guys, all right? I'm the Chief Wizardry Officer at a company called Platform 45, and just like everyone else, we are hiring. Yeah. We're a company that does software, mostly in Rails, so yeah. So today I'm going to be talking about static type inferencing in Ruby. So first of all, I'm going to just kind of discuss what it is, so we're all on the same page. So it's kind of broken up in these three words: type, infer, and static. So I decided to look up the dictionary definitions of each of them. So type is defined as a category of people or things having common characteristics. I don't know if that definition really maps to software directly, but you know, it's like things that have a common interface, I guess. And inferring is to deduce or conclude something from evidence and reasoning rather than from explicit statements, so an implied deduction, I guess. And static is not able to be changed during a set period, for example, while the program is running. This one's specifically like a software definition of the word static. There was a whole bunch of other stuff about like electricity and shit, so I thought that didn't really apply. Yeah, so based on these three definitions, I kind of like smushed them all together and decided that static type inferencing is to deduce from reasoning the categories of things that are not able to change while the program is running. Is everyone happy with that? All right, cool. All right, so basically what it means is that if you write x equals 1, you can be like, cool, x is an integer, right? Sweet. And you can do that just by looking at it. There's a few other things, like if you define a function that takes in an object and you know x takes an x and is x plus 1, you can also infer, okay, well, foo1 will also be an integer. So yeah, so now we know what it is. I'm just going to talk a bit about why it is. So one of the biggest reasons for static kind of anything is to catch things before you run them. So catch bugs that might happen before they get to production, like this. I mean, hands up if you've had this in production or otherwise. Yeah. So, but you might be asking, okay, wait, that's what tests are for, right? Like, we don't need this static shit. And like, yeah, but your tests won't catch every edge case. Like, even if you have 100% test coverage, you're not going to have 100% possibility coverage. So static type inferencing can even catch those things as you're typing. So if you've ever used a static language like Java in an IDE and you're typing da-da-da-da-da-da, and it's like, oh no, you know, this method doesn't exist. I was like, oh, sweet. It also helps your code kind of more self-documenting. So if the thing that you're working with is statically analyzed, then your editor or IDE can pop up things to help you, so you don't have to ask the senior like, hey, does this method exist on this function or whatever. So yeah, so you can get something like this where you like start typing and it gives you a whole list of things. You don't even have to like dig around or look at documentation. It's right in there. And you know if it's in that list that that function exists and you can call it. So the next thing is, why Ruby? Because because of this. I mean, this is like my biggest pain point. Like, of all the undefined methods, something for something, this is like by far the #1 thing I get. And it's kind of irritated me. So I figured, yeah, and it also, I mean, Ruby doesn't have it yet because it's supposedly they're working on some kind of statically thing for Ruby 3. But in the meantime, I thought, you know, why don't I look into it myself? Yeah, so Ruby is notoriously dynamic. Here's an example of some of that. I mean, imagine doing that in Java. And I mean, it's not just that. Like, we've got define method, instance eval, method missing, send, like all these crazy things. Like, how are you even supposed to statically analyze that? But I think it'll only make Ruby better and easier to work with. And Yeah, so you'll get all of the type safety with none of the runtime cost, because like you can get gems that can do type safety, but they do incur a runtime cost by, checking it at runtime. So also, I'm completely insane. Cool. So now we know what it is. We know why it is. So how do we actually go about doing this? So how to infer type? This is a simple step-by-step approach. You parse the code, you infer types of literals, do a whole bunch of other magic, and yeah, there we go. Bob's your uncle. Okay, well, something like that. So first of all, there's a gem called Rubyparser, which is really cool. It turns this into this. And I really like their abbreviations of all the expressions, because this, I call it the lasagna expression, and this is the lit expression. Yeah, but cool. So now we've got a way to take Ruby code and break it down into a data structure or an abstract syntax tree or whatever you want to call it, and then it's on to actually processing it. So if you take, say, a lasagna expression and a lit expression, you can kind of think, okay, cool, so I'm just going to say in my list of local variables, there's one called x, and it's, say, a type integer. Cool. Well, it looks like we're going good so far, and then you just kind of keep doing that with every other kind of expression in the entire language. So okay, we can do assignments. Let's try method calls. So if we've got 1 plus 1, that's a pretty easy one. It goes down to this. So it calls the plus method on whatever it is. So it's lit1 plus lit1. And you can kind of look at that. Okay, cool. Integer has a plus method that takes an integer and returns an integer. So you can say, cool, that whole thing returns an integer. There. Cool. And then you can kind of move forward. So if you're defining a method, this is what it looks like with Rubyparser. It's a defin. It gets the name. It gets an args expression with all the args in it, and then the body of the actual function. So this is exactly that. So it's calling plus on lvar, which is the gets local variables. Yeah. So you can kind of look at this and say, cool. So foo accepts a. And plus gets called on a with an integer, and it's the last expression in the method, making it the return value. So you can say foo accepts one arg that has a plus method that takes an integer and returns whatever that returns. Cool. All right. Looks like we're getting somewhere. Now we also need some kind of internal representation of that. So I was racking my brains, and I figured, okay, cool. So if we were to take that English and kind of turn it into something computery looking, it would be here we've got foo, it accepts a. Oh, shucks. That was supposed to be a duck. But, yeah, well. Because, duck typing and all that. So foo takes an a, that's something that has a plus, that takes an integer, that returns something, and that is what foo returns. So I had something like this, and I was building out, imagining the entire standard library in this crazy representation, and went down that rabbit hole. But it looked like I was getting somewhere. I was pretty chuffed with myself. And then you get to something like this, which is I know it's not a real function, but you'd have all of these things in a method in Ruby, and it's perfectly legal. This is 100%. And this isn't even crazy. This isn't even metaprogramming. This is just Ruby. And this is what it looks like when you parse it with Rubyparser. So, I mean, you've got what's it? We've got this foo, now you've got args. And now you've got a lasagna method, a lasagna expression inside your args. And then you've got quargs. And splats just come through as just symbols with asterisks in them. It's just I don't know what this is. And it just throws it at you, and you have to parse it. And then, this is a weird one. When you have a block that has a rescue, it's a rescue expression. And then it's got a res body. Dynamic strings are pretty cool because they're dstrs, and they have evstrs in them. And yeah, so I mean, a gvar, I didn't even know that thing existed. Oh, that's the global variable dollar bang. Yeah, so that's the yeah. And then I'm calling the retry. So I took one look at this, and I'm like, good heavens, I'm never gonna get this talk done. So yeah. And that's just the surface. Like I said, Ruby, I think is a bit of a mess of a language at this point. Define method, instance, eval method missing, and send. I still haven't even touched on those. I was kind of losing hope, and I figured, it's almost impossible to look at a piece of code and say definitively what their types are. The only way to know the type of anything in Ruby code is to run the code. Yeah, cool. Thanks, everyone. Any questions? No, wait a minute. What if we ran the code statically? So, basically a Ruby runtime that doesn't have any side effects. You just explore every code path in your application from start to finish and raise the same errors that you would have gotten if you really ran it, but without actually running it. Right, bear with me. So, what the hell is wrong with my emojis? Oh well, I'll work with this. So, you got foo a takes a plus 1. If you pass it with 1, that's cool. If you pass it with nil, then some male ghost that looks like a nutsack's going to come after you. Yeah, cool. Sweet. All right. And then I came up with this crazy idea. So you got if statements with quantum scope. And I thought that sounded pretty awesome. But I mean, basically what it means is that, let's say you've got x, and if something that we can't really statically understand could be true, could be false, you set x to 1. So now in this case, you say, cool, x is maybe 1 or nil. And then from then on, you can start doing interesting things. Like you have foo a plus 1, and you call it with x. Your code can say that there's an undefined method plus for nil class, even though x could be a 1, but it could be a nil. So you could have an undefined method plus for nil class. And you can also go and do this where, and I kind of stole this idea from Crystal, because that's how they do their statically analyzed Ruby-ish looking code, is when you do something like nil or is a, within that block of code, it actually pretends that that thing is that thing, because naturally that's exactly how the code would run. So you can do interesting things like this, where you can, by doing this method, the undefined method error at the beginning when x could be nil, it forces you to have to then write an if x is nil in order to actually write some code without it shouting at you. Cool. And then, you can, since Ruby's also got mutations, like you can push into an array, and then arrays have types, you can also kind of do something like this. So if you reach a is in square brackets, it's an array of type something or nothing, and then you push a 1 into it. Okay, it's an array that has integer. You push a nil, now it's got an integer and a nil. So when you sample it, it's a maybe int or nil again, and then you can get the similar kinds of errors. Modules and refinements are something I didn't actually get to, but I've thought about them, and recursion and detecting. So you could detect infinite loops statically, perhaps, maybe. I actually didn't quite try that. Monkey patching I actually did quite early on, because technically when you create a class in Ruby, you're just monkey patching a class that doesn't exist yet. Metaprogramming is, it's still a tricky one, but I thought about it. So you could do something like this, where you've got foo, bar, and baz, and you're defining each method. Like, you can detect statically just by looking at that the thing's going to have a method foo, bar, and baz defined on it. So you can, it's absolutely doable. So so basically you just have to do just enough execution to know what's up, and then we can also do dead code detection. So like this, if true, else part's never going to run. Or if you do something like this, I did this when I was learning how to program once. I did 1 less than 10. I spent an hour, I didn't know what was going on, but it turns out my variable name was L, and my font made L's and 1's look the same. Yeah, another thing is like this is a monkey patching thing where you can go and just say, okay, you know what, instead of like fixing the actual bug, I'm just going to monkey patch the less than method on integer, and then there we go. Suddenly it's not impossible. I love that. Cool, so how is this, does this whole thing actually look? And I came up with a little thing that I call Will It Ruby, because it's basically asking the question like, will this piece of code run on a Ruby runtime? Will it Ruby? So yeah, without further ado, I do in fact have a demo. If I can find it. Oh, there it is. Okay, cool. Right. So I wrote this little like web-based playground thing. Oh, no, there it is. Okay, cool. Can everyone see? Okay, so disclaimer, this is not being run by Ruby, but it can in fact do things like tell me nil class cannot be coerced into an integer, and I mean, let's start with some basic stuff, right? So like nil plus 1, nope, that's not allowed. But I'll give you an example of like quantum if scope. So here's an easy one. So if we have nil.sample, ooh, this may be, it's an integer or a 1, and then I can say, I can give this to x, and then x plus 1, and there we go. We're complaining that it's undefined method plus for nil class because it could be a nil. But again, if you say x is nil, and you say 0, else you know, x plus 1. Now it's returning 0 or 2. So it could be 0, could be 2, and it's happy with this. Yeah, there was actually some other interesting things as well. So like, if you have something like neither of these things have the plus operator, and you go like x plus 2, you can get like an error on both paths of the if statement with different kind of things. So it's like, no, that's a nil, no, this is a symbol. Yeah, and I mean like, I've done a few things like you can have like a map, and x is, let's say, that, and then y is x dot map a is greater than 2. Now it's a false, false, true, true, but if I go y dot sample, it's false or true. So yeah, I didn't have time to do any of the metaprogramming stuff, which I thought, in retrospect now, I probably should have like started with that because that would probably have like a much bigger wow factor. But yeah, thanks. All right. Actually, don't recall if I had any more slides after this. Oh shucks, I've lost it. Where's my presentation? Oh, there it is. Okay, cool. Oh yeah, that is the end of it. Cool. So yeah, I hope that was interesting. Anyone have any questions? Like, I started it the day before, like, well, I don't know about the day before, but I was like just before GitHub added free private repos. So like, made the whole thing on GitLab because it was like free private repos, and then GitHub was like, oh, by the way, free private repos, and I was like, oh, I gotta move the whole thing over. But yeah, so I can actually do this. Okay, cool. It's public.